Hello everyone, I'm Bart Massey. Welcome once again to Intro to Programming in Python, where today we're going to talk about programming style, which is one of those topics that the bigger your programs get, and they're starting to get big these days if you've been following along with this, the more that you have to think about writing for your code to be read. So that's the basic topic that we're going to think about today. So what do I mean by code is for people to read? What I mean is that if computers run it, that's great, but that's more a happy side effect. We love it when computers do the right thing with the code, but the first and foremost duty of a piece of code is for people to be able to read it and understand what the computer is going to be doing and understand that that is the right thing, be able to verify that is the right thing. So having humans be able to understand computer programs is super important, but it's also super difficult. Communicating intent is hard. Computer programming languages are very precise, and that's partly because they need to be precise for the computer, but it's also partly because we're trying to describe things that it's really important to get right. And in real life, we tend to slop around a lot, and that leads to some horrible problems in some situations where people aren't sufficiently precise. But the good news about being with computers is that if you're not sufficiently precise, the computer probably won't understand it anyway. So it's really important that you think hard as you write your program about other people reading it. And other people here, and this should be on the slide, I think I'm going to actually just add it right now. Other people should include future you. Every experienced programmer has had the experience more than once of looking at a piece of code that they wrote some time ago and trying to understand what they were thinking and what they thought that code was supposed to do when they wrote it. I have that experience regularly, and the more that my programming style improves, the more that I can work on my own code later. And later doesn't have to be very long, right? If you write something in an evening, the next morning you come back and try to figure out what it was you were thinking when you wrote that code. Well, that's when having good programming style can help. Let's start with code formatting. Formatting here meaning arranging the text of your program so that it is a properly formatted text. Python's helpful in a way because it requires you to indent your code in some reasonable fashion to work at all. But there's still lots of room to do weird formatting, and we try not to do weird formatting. Well, what is weird formatting? Well, there's a document called PEP 8, Python Enhancement Proposal 8, which is misnamed because it isn't a Python enhancement proposal at all. It's a style guide for Python code. Guido van Rossum, the original creator of the Python language, and until very recently, the person who made all the final decisions on the Python language, and a couple other people wrote this stuff 20 years ago, and it's still as valid as when it was written. It's absolutely cool. I'm not going to read it to you because this isn't that kind of video, but I would encourage you to skim it and try to understand it in the parts where you're familiar with the basic concepts. It starts with some simple things. I'll give you some highlights here in a minute, but the point is this is a very readable document that I strongly recommend that everyone who's going to be programming in Python read. If you're not going to be programming in Python, in some future programming language, they'll have formatters and documents about formatting and that stuff too. It turns out to be an important topic. It turns out that we have good especially good descriptions in Python of what the Python people think Python programs should look like. So yeah, please at least skim that and read the parts that seem worth reading. Here's some key ideas from PEP 8. First of all, the formatting of expressions. It's really important to have spaces around operators. We write things like this is considered really bad form. because it's really hard to read. The eyeballs in the brain are very much optimized toward reading things chunked in words, especially since you've had something like 12 years of training in reading words. And so the more you format this like natural language text, the easier it's going to be to break down. And so really having this extra spacing in here is a huge readability win. This one is questionable. I usually write exponentiation tight because it really should be superscripted, but if you write it this way, nobody's going to be mad at you. It's certainly nice to be able to see what's going on. On the other hand, PEP 8, like most documents for programming languages, does not recommend spaces here. Things like parentheses and other kinds of brackets, you don't normally space there because it just makes it harder to read instead of either. People are used to looking for a thing inside the brackets with no space. So that's the spacing rules. Indentation is 4 spaces. If I write a thing here, the official formatting is 4 spaces. And if I'm using a text editor, when I hit the tab key in Python, it should actually insert 4 spaces. If it doesn't, you should reconfigure your text editor or pick a different one because that's what it's for. But that is the standard Python indentation, and you should always be using exactly 4 space characters as your indentation thing. What else? There's a whole section in PEP 8 about doc strings for functions. That's really only useful if you're going to be publishing modules for other people to use. I would say ignore it for now. I prefer, honestly, to excuse me, to use an ordinary comment instead of a doc string. Most names you're going to encounter early on should be formatted snake case. So that's lowercase with underbars for the spaces. This is a snake case formatted name. In Python, we don't make variable names like this. We don't make variable names like this. We don't make variable names like what are the other choices? I don't know. There's a million ways people can format. We don't make them all caps in any form normally. So normal variables, normal function names, that kind of stuff should be named in snake case, and that's just the PEP 8 official thing, and it's what you should be using. I mentioned commenting. Commenting is super important. You really want to pay attention to commenting your code, especially when you're starting out. It's important to sort of sprinkle your notes into the code because you don't have notes normally anyplace else. I sort of insist in this course that every file start with a 2-line comment. The first line should describe what the file is and does. It should be a sentence like, a sentence fragment like calculate pizza area or whatever the program does. The second line should be your name and the year that you're writing this in. That information is great for later to find out who wrote what and when it was written, at least roughly. Every function defined in your program should have a comment at the top to describe what it does. What does this function take for arguments? What does it return for a result? What does it compute? It's important to comment anything that you think might be confusing or complicated to understand. If you've got some weird arithmetic trick or some strange control flow, a comment there would be really helpful so that people understand what it is you're doing. If you used other people's code or ideas or whatever, if you got something from Stack Overflow, for example, where you use it in your program, that's fine, but where you use it in your program, there should be a comment that explains where you got it from. That's important for a couple reasons. One is so that you're not accused of stealing other people's work, which you don't really want to be, but also because if it's messed up, which Stack Overflow often is, then you want people to understand that that wasn't you, that was them, and your only mistake was not understanding something well enough before inserting it in. Absolutely critical that if you get stuff from outside, put a comment in where you use it. Finally, a really common habit of beginning programmers is to put debugging and testing code and trying things out and stuff as they write their programs, and then commenting it out when they're done with it rather than deleting it. That's a real bad idea. Your code eventually becomes very difficult for people to read, including yourself, because there's this mixture of comments that don't mean anything and are just glop code left lying around. It doesn't take that long to type a line. If it does, you should practice typing. It's fine to comment stuff out temporarily while you're debugging or trying things out or whatever, but sort of the minute you're done with it, delete it, get it out of your program. It's served its purpose. It really, really hurts readability to do that. Finally, there's some tricks to reduce complexity. This is a complicated topic, and it's more than I want to cover in this brief discussion. But what you'll find is as your programs get bigger, commenting's not going to be enough. You're going to want to actually make the programs less complicated, easier to read sort of naturally. And that includes things like breaking up long expressions using variables. So here I'm computing some distance. I don't know why I didn't just type out distance there. I don't like that at all. I'm computing some distance, and the first way I could do it is I could type a really complicated expression for the distance, right? That thing apparently takes two variables, x1 and x0, subtracts them, squares that, adds it to y1 minus y0 squared, and takes the square root of the whole thing. Well, even formatted reasonably properly like that, that's a hard expression to read. And there's no reason to make it hard to read. You can give names to the pieces. And the way you do that is you use variables. Use variables to store pieces of the expression. So here, the difference in x is going to be x1 minus x0. The difference in y is going to be y1 minus 0. The distance squared is the difference in x squared plus the difference in y squared. And then the distance is the square root of the distance squared. This is a lot easier to read, right? It's 4 lines instead of 1. But each line does something that's pretty easy to understand what you're doing and why it's doing it. That's a great way to reduce your code complexity. Variables are free. Don't be afraid to use as many of them as you would like. Also, when you have complicated control flow, which you eventually will as you start to use if and while and for a lot, using Boolean expressions and breaking code out into functions to reduce that code complexity will be something we'll talk about a lot in the future. A less complicated program is a better program, pretty much always. Finally, a good way to learn good programming style is to read good code. I have examples that I've been presenting of code that I think is done in a reasonable style. The textbook we're using has examples of programs that I think are written in a reasonable style. The internet is full of Python code that I think is written in a reasonable style. If you go out and just look at that and see what they're doing and sort of compare it to what you're doing, you may get some good ideas about what people are looking for in code and what you might be trying to achieve. I mean, this is the thing that comes over time, writing good, well-styled programs, but it'll come much quicker if you're trying hard. And so you need to try hard, because this is one of the most important things in getting good at programming, is producing programs that are done with reasonable style. I hope that was helpful, and I look forward to chatting with you again soon. Please stay safe and well out there during these difficult times, and I will talk to you again shortly. Take care.